Okay, at first look, this is a kind of difficult looking problem, but after we talk through it, hopefully it'll make pretty good sense, won't be too bad. So basically we have two lines, L1 and L2. These are non-vertical, they're intersecting lines, and then we have this theta that's kind of in the middle, in between these two lines. It's that angle that's created between these two lines, L1 and L2. Our end goal of this is to show that tangent of theta is slope of this M2, the second line, L2, minus the slope of L1 over 1 plus this slope multiplied by this other slope. All right, so let's talk through the key things for this. All right, the first thing to note is let's try to represent our theta in terms of theta 2 and theta 1. All right, so to do this, what I'm going to do is just draw a nice horizontal line kind of going across here. Let's think if we had this and we took away the smaller angle. So what I'm suggesting is that theta is going to be the same thing as if you take the bigger angle, theta sub 2, and you subtract away theta sub 1, those will be equivalent. What's left over is kind of that missing part, exactly where the theta is in the middle. Okay, that's the first thing. All right, the next thing is kind of given to us over on the side here, the fact that tangent of theta sub 1 is equal to the slope of that line, and then tangent of theta sub 2 is the slope of that line. All right, let's talk through that. So if I kind of mimic what we had going on with, let's call this, let's use this as theta 2, theta sub 2. And if I drop a line straight down here, actually let's over-exaggerate this into a triangle. So theta sub 2 is going to be here. We've got a y value. We've got an x value. Let's think about how would you calculate the slope of that line? Well, the slope of that line would be given by, you could think rise over run. All right, the distance you travel vertically would be y, and the distance you travel horizontally would be x. All right, but then let's connect that with, in this case, tangent of theta sub 2. Well, we could think of tangent as meaning opposite over adjacent. Opposite on this side, adjacent on the bottom. Well, that matches up to be y over x as well. So since these work out to be the exact same thing, that's why we can say that the slope of the theta sub 2 is equivalent to or equal to the tangent of theta sub 2. All right, so putting that all together, we know that tangent of theta is going to be given by tangent of theta sub 2 minus theta sub 1. And just filling into our difference formula for tangent, it's written right up above there. You can say this is tangent of our bigger angle, theta sub 2, minus tangent of our smaller angle, theta sub 1, over 1 plus tangent of theta sub 2, multiplied by tangent of theta sub 1. From here, we just need to plug in, basically. Remember, we just said that slopes are equivalent to tangent of their respective angles. So in our case, we can replace tangent of theta sub 2 with m2, the slope of that line, minus tangent of theta sub 1 is m1, slope of that line, over 1 plus m2 multiplied by m1. Now we could, of course, flip-flop these because they're multiplied together. Commutative property of multiplication says you're welcome to flip-flop those, go the opposite direction. So it's going to be the exact same formula we were trying to prove. So I hope this helps out as you're working through these, trying to understand, break it down into small pieces, and work with that as you go. Use what you know about slopes and tangent and SOHCAHTOA. All right, hope this helps out. Good luck.